Okay. Let's say I'm going to put the pictures away.
Professor?
Okay.
Hello.
Hi. Hi.
I was just saying that I was not able to access last lecture's recording. I tried to look for it, but I couldn't find it. Was it recorded?
Yes, it was recorded, but it was on my I think yes, it was recorded, but it was on my laptop. You want me to record it on Zoom?
Yeah, because I clicked the cloud section and I didn't see any recordings there.
Okay, sure. Okay, so I'm saying now I can just don't worry, I'm going to upload it. I'm going to upload the recorded lectures somewhere, maybe on YouTube, and post a link on Canvas tonight.
Okay, that's great. Thank you.
Okay. So
Yep.
okay, and last time when we finished the insertion sort algorithm, we discussed something. So I'm going to cancel, do not disturb. Okay. So then when we discuss say the another concept named time complexity. So we said that the time complexity will not directly help us to tell how long is the program going to execute, but instead it's going to give us a sense of how long is the running time, with how fast does the running time grow with respect to the size of the input. So we said that we care mostly about the worst case. Okay, so in the worst case, how fast is the growth, and we give it we usually use a notation named Big O. Big O just if you write down Big O notation, Big O is almost like the horsepower thing in a vehicle world. So if you say HP for a vehicle, you definitely know that it means horsepower. And for algorithms, if you talk about Big O something, everyone is going to relate to this to worst case time performance, the worst case time complexity. And so what is the worst case time complexity of insertion sort?
O(n) squared?
Yes, O(n) squared. Yes, nice. And so this is pretty much everything that we discussed from last week. And I'm just wondering if any one of you have already started your homework one.
Yeah, I did.
Okay. Any other one who have already started that?
Yeah, I started it.
Okay.
I started it.
So is there anyone who already finished that? Wow, I submitted. Cool. Yes, I see one student. Oh,
I have a
nice.
question about the graph.
Okay.
So like, do I plot it in Excel or Desmos, or do I just free draw
Excel is
it?
fine. Excel is good enough.
And do I have to use the data from the last compile? Like
What
the
do you mean by
timing
the
and
last
then
by your execution, right?
yeah.
Yes.
Okay. All right. Thank you.
No problem. Okay, cool. So great. So if you have already finished that, how long does it take?
8 minutes. It took me 8 minutes.
8 minutes?
Yeah, because the values were in 100,000s. So for some reason,
no. I don't say how long is the algorithm. I mean, how long does it take you? How long does
it take you to do the homework?
Is the execution? I mean, how long does it take you to complete the homework? I was really shocked when you say 8 minutes. Like,
oh no, I thought you asked about 8 minutes.
Probably it will take me 8 minutes, 10 minutes, something like that.
I thought you were asking about the compile. No. Okay. It took me good 2 hours.
2 hours?
Spent some time. Yeah, I did. I went.
Answer? We got 2 hours.
Yeah, from what I heard from other people, it took them about 2 hours.
Okay.
Yeah, it took me like 1 or 2 hours.
Okay, cool. And 2 hours, cool. Yes, this if you can finish this homework within 2 hours, it means that your Java background is pretty solid, and so you are going to have a very smooth start with this course. But for those of you who are not familiar with Java, or say if your Java background is not good enough, the story is going to be very different. So if you are say if your Java is not very good, expect 8 hours. Just leave 8 hours. You don't want to only leave like 2 or 3 hours and get everything messed up. Okay, so great. And so today we're going to have 2 topics. The first one is the merge sort and its time complexity analysis, whereas the second one is basically it's more like a tutorial session, or a Java review session for me to teach you some basic things about Java, something that you will need to do the homework. And also, I'm going to teach you something on the debugging, teach you the debugging features in Eclipse. So, but first we are going to just learn the merge sort algorithm, which is the second solution to the sorting problem. So in insertion sort, we basically solve the problem incrementally. So in the first, if you remember that in the first iteration of the for loop, by the end of the first iteration of the for loop, we got the first 2 numbers sorted, and then we got the first 3 numbers sorted, first 4 numbers sorted, etc., right? So in every one, we basically increase the solution size by 1. So the solution, meaning that by solution size, I mean the number of elements that have already been sorted. So in the first iteration, the solution size is 2, and then 3. So we keep doing that until the solution size reaches the same reaches the array size. So that is one procedure, or one way to get a problem fixed. And then so today we're going to say how can we solve a big problem from a different perspective. And there is a logic or a design philosophy named divide and conquer. So we're going to learn 3 algorithms that use this design philosophy later in our class. So it's very important. And and what is divide and conquer? And if you go to read the book, it has 3 pages of text like this to explain you what is divide and conquer. And actually, it is pretty boring for you or abstract for you to understand it. So I'm going to try to explain this procedure by using a real world example. Suppose here, okay, you got you have a grandparent, and so here, let's say your grandma has an old car parked in her, say, parking lot or parked in her garage. Well, this car is totally dead. So this car is not drivable at all. So but it's still in a whole shape, like it's still something like this. And so this is let's say this is the garage. And what one day, say your grandma calls you saying that, okay, can you help me to move my car to for example, to a junkyard? Okay, so your grandma is going to asking you to help to move the car to the junkyard. And the bad thing is that she's not going to give you any penny for that. So you cannot get a tow truck for it, and you have to do it by your hand. So how are you going to move the car, this junk car to the junkyard?
You take out like the inside, the internals,
Oh yes.
like the engine.
Yes, we already got some good some answers which I expect. So so the logic is this. Okay, this car is definitely very heavy, like more than 1,000 pounds, and even more than even around 2,000 pounds. So you cannot move it by your hand to the junkyard. So in a whole. So what you are going to do is that, okay, you are going to divide it or cut it into small pieces. So for example, for one time, just take off the wheel. Okay, you just take off the wheel, and then you move the wheel. You use your own car to move the wheel to the junkyard, and then say move the tires and the wheels to the junkyard, and then someday you take off the engine, and then use your own car to move it to the junkyard. And okay, so so after you move all the pieces into the junkyard, you reassemble them into the original car. So then you get this very difficult job done, right?
Yeah.
Yeah. Okay. So here you are giving a very difficult work, and the way for you to do it is that there are three procedures, is in three steps. So this is the first step. The first step is called divide or cut. Basically, you divide this big car into different pieces that are movable by your hand. And then the second step is, we call it conquer or transit. So you transit or you transfer those small pieces to the junkyard. And then here is the last step. Here you got the last step. The last step is to combine or reassemble. You reassemble this after you move all the small pieces to the destination. You reassemble them into the back to the original shape of the car. So then after these three steps, you get this job done, right? So
Right.
okay, and this procedure, these three procedures are called divide and conquer. So in divide and conquer, we have three steps. We usually have three steps. Divide is to divide the problem into a number of sub problems that are smaller in sizes and smaller in difficulty and easier in terms of difficulty. And then conquer is to resolve each sub problem individually. And then combine is to combine the solutions to the sub problems into the solutions for the whole problem. Okay, so these are the three different steps. Okay, so this is if your procedure or your algorithm follows this three different steps, then we say that your algorithm uses the divide and conquer paradigm or design philosophy. And actually this philosophy is widely applied in computer science. So if we're giving a very big problem, we divide it into small pieces to make the solution feasible. So this is the divide and conquer paradigm. And so before I continue, any question with this?
No question.
Okay, so then I'm going to proceed. Okay, so so when we want, here what we want to do is that we want to apply the divide and conquer philosophy to help us design an algorithm a sorting algorithm. And the way that we designed is like this. So I'm going to add a new page over here. So the way that we resolve this problem is like this. Okay, so suppose here we are giving a very long array to be sorted. And okay, after receiving this array, we said, okay, this is too difficult because it has too many elements, and we don't even know where to start. So we want to reduce the level of difficulty by cutting or dividing this big problem into two sub-problems of the same size. Okay, we divide this very long array into two smaller arrays of the same size. And then, okay, after seeing these two smaller arrays, we say, okay, it is still too big. And then we further cut each of them. So we got this. And we also divide each of them into two smaller arrays of the same size. So now we got, now we got 4 smaller arrays. And after looking at each of them, we said, okay, still it is too difficult. We want to keep cutting it. And we just divide each of them into, we further divide them. And so we got 8 small pieces. And actually we're going to keep dividing them until each of them size is only 1, okay? Until we reach the length 1 status, meaning that all the subarrays only include 1 number. Okay. So here we got just use this as an example. After so at the end of the divide, at the end of the divide step, we got 8 small arrays, and each of them only includes 1 number. So now I'm going to ask you one question. Okay, if I ask you to sort this array, if I ask you to sort this array, what are you going to do? How are you going to sort this array that only includes 1 number?
Wouldn't it's just already sorted?
Yes, it's already sorted. Great. So it's already sorted because it only includes 1 number and there is no comparison. So by itself, itself is automatic. It is automatically sorted. And so up to here we say this is the divide step. This is the divide step. And then the next step, the next procedure is to what we call is concur, is to basically solve each sub problem individually, or sort each of these subarrays individually. And the procedure for us to sort each of them individually is pretty straightforward. We don't need to do anything. We just keep the subarray in its original shape, in its original order, because each of them only includes 1 number, and we do nothing actually over here. We basically do nothing in the concur step. Concur meaning that we solve each sub problem individually. So in the concur step, our life is really easy. So we don't need to do anything. And then finally, it is the combine step. So if you remember in a car example, so in the combine step, we just reassemble different parts back to the original car. And similarly over here in the concur step, in a combine step, what we do is that first we are going to compare the first 2 subarrays, sorted subarrays, into a longer say sorted subarray. So originally we got two small arrays. Each of them only includes 1 number, and each of them is already sorted. So after we combine them, we got a length 2 array that is sorted. Okay, and similarly we combine the 3rd and the 4th, and the 5th and 6th, and the 7th and 8th. Okay, we just combine 2 by 2, and so now we got the length 2 arrays that are already sorted. So we say each. I'm just marking them with this to denote that they are sorted. Okay, they have been sorted. And then in the next round, we are going to combine the 1st and the 2nd subarray over here, and to get a length 4 array that is sorted. We're going to compare the third and fourth subarray and length 2 subarray and get a length 4 array that is sorted. And in the last step, we're going to combine those two sorted subarrays into a bigger and sorted array. So then this is this is the output that we are waiting for. This is because at the last we will get an array that includes a sorted array that includes all the numbers, all the original numbers. And we say this step is called, we call this step combine. Okay, so this is how we use the divide and conquer procedure for us to help us design the sorting algorithm, and we call it merge sort. We call it merge sort. Okay, so any question with regard to the procedures?
Yeah, we're gonna see it like actually with the array of integers too, right?
Yes.
Okay. I'm a little confused when it's just boxes, and it would help seeing numbers.
Yes. So here, everything. So each box is basically an array of integers. Each rectangle is basically an array of integers. So so if no problem, then I'm going to ask one question. Okay. In your mind, out of these 3 steps, which one is the easiest?
I think
Combine.
the conquer one is for me.
Yeah, me too. Conquer. I would say
Yes,
conquer too.
conquer. This is the easiest one, because if you are asked to implement the conquer function, you don't do anything. You just return the array. Giving a length 1 array, you just return it, right? Okay.
Correct.
So okay, yeah. Okay, I got one question. I'm going to read it. So every time you combine the subarrays and they get sorted, right? Yes. So in every combine step, we are going to combine two small sorted arrays into one big sorted array. Okay, so this is what we do with the combine step. And then, so out of these three steps, which one is the most difficult?
Combining.
Yeah, the combining one.
Yes, this is the most difficult one. Sorry, I just write the same word. This is the most difficult one. And with regard to the divide, it's also pretty easy. So we just need to find the middle point of an array and cut it from there. So we're going to see that function later.
We're not gonna be trying to get the median of it, right? We're just that's what we're writing, correct? That's what we're
Yes,
trying to.
we're
Okay.
correct. We're not trying to get the median value. No, we're just getting, okay. So suppose that this index is 0 and this index is 7. So we just find, okay, where is the middle point between the index 0 and 7? Let's say it is 3 and 4. So everything whose index starts from 0 to 3 is going to be included in the first subarray.
All right, I get it now. Thank you.
Okay, so it's like we're not worrying about the values. We're just worrying about the location.
Okay, thank you.
No problem. So here, and actually there are two there. So because we do nothing in the conquer, so there is no function for the conquer. Whereas and the most difficult function or part is in the combine, and we have an algorithm named merge to help us do the combine step, and then to help us do the divide and then call the merge. So we have a function named merge sort. Okay, so next we are going to study the merge function because it's most difficult. And then we're going to briefly go over the merge sort function. So it's going to be very easy for you to understand it. So, but we are going to spend most of the time with the merge, and it's hard for you to understand it. So, and this is the pseudocode of the merge function. So let's say the merge function, that this is in the first line. What is the first line? What does the first line do?
Is it merging 4 arrays?
Mm-hmm. We talked about the purpose or of the the top line of a function in last lecture. So what do we use this line for? Function declaration, right? Declaration. So it's like now we're going to declare saying that we are about to define a function whose name is merge and whose input parameters are a, p, q, r. So so what does the capital A stand for? What does the capital A stand for?
Isn't it the array?
Yes, capital A should be an integer array. Cool. And then we have PQR, right? We got a PQR. So so what does PQR stand for? I'm going to show you it next. I'm going to write it down over here. Okay, suppose here in the array we got 2 consecutive subarrays. We got a very long array. This array is extremely long, and we're just looking at part of it. And here we got two consecutive subarrays that have already been sorted. So we call this the left one, and we call this the right one. Okay, so the right subarray and the left subarray, and they are just a part of the whole array. Okay, so our task is to merge the left and the right subarray in which have already been sorted. These 2 subarrays have already been sorted. Our task is to merge the values in these 2 subarrays so that we can get a longer and a long subarray that is sorted. Okay, so this is our task. We want to merge the values from 2 sorted subarrays into a longer sorted subarray. And so what does PQR stand for? P stands for the beginning index of the left array, and Q stands for the ending index of the left array, and R stands for the ending index of the right array. So with PQ, you know that for the array A, from P to Q is the part of the left array. The subarray whose index starts from P to Q belongs to the left subarray that we want to merge. Is that clear?
Yes.
Yeah.
Okay. So then so which part belongs to the right subarray?
Q to R.
QR.
AQR, yeah.
No.
The A bracket QR.
No.
Isn't it?
No. Not exactly. It is this Q plus 1 R.
Oh, okay.
Oh.
Right? So because these 2 subarrays, there is no overlap between these 2 subarrays. So but the right subarray just follows the left subarray. So the starting index of the right subarray is just Q plus R, where Q is the ending index of the left subarray. Sorry. Make sense?
Yes.
Yes.
So everything so in the array, everything whose index starts from Q plus 1 until R is the right subarray. Okay.
Because if you were to do QR, then it would be counting Q twice, right?
Yeah,
Yes.
that's what I was thinking. Yep.
Yes. Okay. So any question with
I'm
regard
good.
to the definition of PQR? So if now I'm going to write them down on so over here for you to understand it after class. Beginning index of the left subarray and ending index, Q is the ending index of the left subarray, and R is the ending index of the right subarray. Okay, so so next let's start reading the pseudocode. And so we got in the first line we have n1 equal to q minus p plus 1, and n2 equals to we have n2 as r minus q. And then we create two new arrays called L and R, capital L and capital R. And we here we got two for loops. And over here we got something else. Ln1 plus 1 equals here. What is this? What is this symbol?
Infinity.
Infinity.
Yes, infinity. Okay, cool. This means infinity. Infinity is like the infinity. But how? Okay, so this means infinity. So I'm going to leave it over here. Okay, infinity meaning the largest value that you can imagine. So and then here we got I equal to 1, J equal to 1, and then we got a for loop, if and else. Okay, so everything seems very straightforward. I mean, from the programming side, from the coding side, there is nothing that is super difficult. We only have three for loops and a if and else statement. So that's pretty much it. But it's extremely difficult for you to understand the logic of this algorithm. So we're going to probably spend half an hour just explaining that. And so I think that when we finish that, for some of you or most of your brain is going to you will feel a headache. And so yes, but it's good. If you feel a headache, it means that you're following me, you're thinking, your brain is running. Okay, so again, I'm going to use an example to explain that. So I'm going to write down the merge. I'm going to write down the pseudocode over here, A, P, Q, R. So we got, first we have n1 equal to q minus p plus 1, and n2 as r minus q, and then we let L 1 and 1 plus 1 and r and 2 plus 1 be two new arrays. Then we have for I starting from 1 to n1. We got Li equal to A P plus I minus 1. And then we got for J starting from 1 to n2, or J equal to A Q plus J. And so we got L and 1 plus 1 as infinity, and R and 2 plus 1 as infinity. Okay, so then we're going to use an example right over here. Okay, so I'm going to write down the example on the right side. So here we got an array A, so which is super long, and a part of it is like this. 2, 4. Two, 4, 5, 7. 1, 2, 3, 6. 1, 2, 3, 6. Okay, so the index of these two subarrays are as the follows. Starting from 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so here I'm going to use a different color to stand for the beginning and the start and end of these two subarrays. Okay, so here this is a test instance. So over here we got an array A, and so it's super long, and so when we are doing when we are executing the merge sort algorithm, so within that procedure where we say a status where the array looks like this, and we got two sorted subarrays which we call the left and the right, subarray over here. So I'm saying so the left subarray starts from the index 9, whereas the right subarray starts from the index 13. So first, let me ask one question: is the left array sorted?
In comparison to the whole array, or just its own, just itself?
Just its own.
Yes, it's
Yeah.
sorted.
Yeah.
Yeah. And how about the right one?
Yeah.
Yes.
Yeah.
Yes. So so here we're given two sorted subarrays, and our task is to merge them into a long sorted array. Okay. So here, if we want to pass in this array to the merge algorithm on the left, so what kind of values are we going to assign to PQR?
Is P2 and Q7?
No,
And no. Okay.
but you're very close.
Is it 9 and 12 and 16?
Yes, correct. If you look at the definition, okay, P is the beginning index of the left
Oh, okay. I
subarray.
see.
So here we're talking about the index rather than the value. Okay, and Q is the end index of the left subarray, and R is the end index of the right subarray. So here, so we got, so what we should get is this. We got P as 9. So this is P, because so the beginning index of the left subarray is 9, and Q is 12. We have Q over here, and then R is 16, right?
Mm-hmm.
Okay, that clear? Any questions so far?
No.
Okay, so next, let's execute so here I just write, for now I just write down the first part of the pseudocode. So let's first focus on the first part of the pseudocode. And so here we got N1 as Q minus P plus 1. So what is N1?
4.
Yes, let's do it. We got Q as 12. So 12 minus P is 9 plus 1, it is 4. Okay, and what does N1 stand for?
Is it the amount of numbers in that subarray? The amount of
Yes, length of left.
Okay.
Okay, so we are using the end index of the left subarray minus the beginning index of the subarray and plus 1. So it tells you how many values, how many numbers, or how many values elements are in the left subarray. Okay, so similarly, I can give you another example. So let's say we got an array, and whose index a normal array, okay, whose index starts from 1 and ending index at 10. Okay, so if you use the ending index, which is 10, minus the beginning index, which is 1, plus 1, it is 10. It tells you how many elements are there in the array. Okay, ending index minus beginning index plus 1 is the number of elements. Okay, so similarly, if you take Sunday as 7, Monday as 1, if you want to calculate how many days are there in 1 week, 7 minus 1 plus 1, so which is 7. Okay, so this is the length of the left subarray. And here next we have N2 as R minus Q. So what is R minus Q?
16 minus 12.
Yes, so we got R as 16 and Q as 12. It is 4. So actually, so what does N2 stand for?
It's the array length of the right side from Q plus 1 to R.
Yes, so length of the right subarray, And so if you don't understand why we got R minus Q, and actually it should be a little bit different. It should be this. What is the ending index of the right subarray?
16.
What is the R? Let's just be general, okay? It is R, right?
Okay.
Okay, so as we previously said, we need to use the ending index minus the beginning index plus 1. What is the beginning index of the right subarray?
Q plus 1.
Yes, Q plus 1. R minus Q plus 1 and plus 1. So can help us to know how many elements are there in the right subarray. And if we extend it, it will be R minus Q minus 1 plus 1. And these two just disappear. So then we got R minus Q. That's why we got it over here. Okay, the length of which is the length of the right subarray. And next, let's look at the pseudocode in the third line. Let L with the index starting from 1 to N1 plus 1 as a new array. So what is the length of L?
5.
5, or to be general, N1 plus 1, right?
Mm-hmm.
Yes. So here we're going to create a new array L whose length is, we're going to create a new array L whose length is 5. So 4, 5, okay. And then, so what about R? How long is R?
And 2 plus 1.
N2 plus 1. N2 is, sorry,
4.
I should have write the values of N1 and N2 down. So because N2 is also 4, so so here the length of the array R should be also 5. Should also be 5. So then we got another array R whose length is 5. Okay, so the index of L and R are starts from 1 to 5. Okay, so next we are going to execute the first for loop for I starting from 1 to N1. We have Li equal to AP plus I minus 1. AP plus I minus 1. So here, what do we use I for?
Like just as a starting point?
No. So if you remember, in our last lecture when we talk about the insertion sort algorithm, right over here, if you look at here, we use I and J. Here we create variables I and J. We use them as the index of the array. Right? We use them as the index of the array. And by default, we programmers, we always use I and J and K variables like this. as the index or index of the array. So here again we use I as the index for to retrieve values, access values in the array L. So here initially we got so if we execute this for loop, in the first one we have I equal to 1. So we got I equal to 1. When I is 1, we have I right over here. And so this sentence, and if we want to translate this sentence to a simple language, let's just substitute all the values. It will be L1 equals A P plus I minus 1. So we got, so because we have P as 9, so it will be 9 plus 1 minus 1, which is A9, right?
Is that playing, does that transfer the index from P to Q to L1? So it'll put like
Yes.
2 to L1?
Yes.
Okay.
Yes, that's correct. Okay. So so here, so if we translate this statement in a better way, it would be L1 equal to A9, right? Any question? Am I too fast?
You're fine for me.
There question? Any question from the class? So if you want me to slow down, I can do that.
No, I think you're fine.
Okay. So next. So with this statement, L1 equal to A9, what are we going to do? We're going to copy A9 to L1, right? So here, what we do is that we copy A9 to L1. So we copy the value over here, and then here we got a value too. Am I right?
Yes.
Okay.
Yeah.
And then, so after we finish this statement, we go back to the for loop and we increase I by 1. So now I becomes 2. So we got I as 2. And then, so this becomes this. So this, the statement on the left, we can rewrite it as something like this. L2 equal to A, P is Q, sorry, P is 9. So 9 plus I, which is 2 minus 1. And 9 plus 2 minus 1 is 10. So L2 equals to A10. So we are going to assign A10 to L2. So what we do is this. Okay, we copy the value from A10 to L2. So here we got a value 4. Okay. So am I correct?
Yes.
Yes.
Okay. And then so so next we're going to increase I by 1 because the largest value that I can have is 4. So now we increase I to 3. So this, and basically we're going to increase the value from the left hand side and the right hand side by 1, because here everything else remains the same, but only I it increases by 1. So this would be, I'm just going to write it in a shorter way. Okay, so previously it was L2 equal to A10, and now we need to increase the index of both the left and the right hand side by 1. So it becomes L3 equal to A11. So what we do is that we copy the value from A11 to L3. So we got the value 5 over here. Right? And then in the next iteration, we increase I by 1. So So I becomes 4. So then this becomes L4 equal to A12. L4 equal to A12. So we are copying values, the value from A12 to L4. So here we got a value 7 in it. So I just got a comment saying that is so for L should it be 2, 4, 5, 7, 1? No. So yes. Okay. So we are not going to copy 1 to we're not going to copy this 1 to L5 because the largest value that I can have is 4. So after copying 4 values, we're done with this for loop. Okay, so we just finished the first for loop, and then we are going to go to the second for loop. So if you ask me if you want to summarize this for loop, it's going to copy values from the left array to L, and then next, so we are going to start the second for loop, and we start with J as 1. So again we are going to use J as the index. So our J. And then so when J is 1, let's translate this sentence to some simple language. It is going to be Rj or R1 equals to what is Q? What is Q over here?
Q is 12.
Yes, Q is 12. So it's going to be A12 plus 1, A13. So we have R1 equal to A13. So what we do is that we copy A13 to R1. And then the value 1 is going to be copied over here to R1. Okay, so next, and actually this procedure is going to be pretty similar to the above. So we keep increasing J, and in each iteration, if we look at this statement, everything remains the same except for J increases on the left-hand side and J increases at the right-hand side by 1. So in the next iteration, when J reaches 2, so it will be something like this. It will be something like R2 equal to A14. We're going to copy A14 to R2. So the value that we're going to copy is this. And in the next iteration, we do this and this. So, okay, and then we stop over there because the maximum value that J can have is N2, which is 4. We are just going to copy 4 values. So here, with this for what we do is that we copy the values, copy the right array to R, to the capital R. So we're just copying the values from the 2 subarrays to some auxiliary array. And then, so in the last round, the last 2 statements are like this: Ln1 plus 1 equal to infinity. What is n1?
It's 4.
It's 4. Yes, it's 4. So this sentence would be L4 plus 1, which is L5. So it's like we're going to copy infinity to L5, right? We're going to assign infinity to L5, and L5 is right over here. So we're going to fill in infinity over here. And similarly, we're going to assign infinity to the last position of the array R, so which is over here. So we're going to give it an infinity value. Okay, so then this is the first part. this is the result after we finish the first part of the merge function. So we basically just we basically created two auxiliary arrays as a copy of the left and the right, but we append an infinity to those two auxiliary arrays. Any question? Are you still with me?
Yeah. What do you do with
Okay.
the infinity?
Sorry?
Or what do you do with the infinity for the last index?
Okay, it will be clear in a couple, maybe in 10 minutes. But I encourage you to keep thinking about the reason why we append infinity. When we go through the second part of the pseudocode. Okay, so and now I'm going to erase the first part and then go to the second part of the pseudocode. Okay, so I'm going to write down the pseudocode of the second part over here. I equal to 1 and j equal to 1 for integer k starting from p to r. So if ai is less than or equal to, sorry, not ai. Now I is less than or equal to rj, we are going to assign ak as li, and we're going to increase I by 1. Otherwise, we're going to increase, we are going to have ak to rj, and j is going to increase by 1. Okay, so this is the second part of the pseudocode. And first, we create two integers I and j whose initial values are both 1. So let's write down over here. And again, we're going to use I and j as the index of the array. So basically, if you go over the following so part of the code, you can see that we are going to use I as the index to the array L and use j as the index for the array R. So I'm going to put I over here and j over here. Okay, the j, I'm going to put j over here. So and then next we create so we have a for loop. In the beginning of the for loop, we have k as p. So k is the initial value of k is p, which is 9. So I'm going to move the left and right side, and k over here too. Okay, because initially k here we're going to use k as the index for the array A. So I'm going to write k, mark k, let k point to the index, write k above the index 9, meaning that so k is here. Okay, so and if you so the ak is just right below the index, this index value ak. Okay, so
Professor, two things. So now I see why you put infinity. And second, this only works because the two sub-indexes are already sorted, right? Arrays are already sorted.
yes, these two subarrays, So if we want to execute the merge function, then you can merge two arrays. Those two subarrays must. Okay, it seems there is a lag in my presentation. Just wait a second. Okay. Can you see my screen now on the page
Yes.
with the arrays? Okay. So if we want to merge, so in order for us to be able to call the merge function, the two subarrays must have already been sorted.
I see. Yeah, I was reading the code. I mean, I'm not sure. I think you could probably do it even if they're not sorted, but you'd have to alter the code.
You have to alter the code a lot, and I mean, the code would be totally different if those two subarrays are not sorted. The code will be totally different. Okay, and we're going to see the advantage of having two subarrays that have already been sorted. So okay, before I go over the for loop like at here, I'm just going to ask you one question, very simple question. Okay, so here, if our class has two, let's say two columns, this is column A and this is column B, and each column is basically a list of students, and in each column the students are ordered from the highest GPA to the lowest GPA. So this is the highest, this is, let's say we got a student called Alice with the highest GPA in A, and Bob in the highest GPA. So in the column B. So basically the students from in both columns are arranged in the order from the highest GPA to the lowest GPA. Okay, so then we know that the student at the top position in the array in the column A is Alice. So Alice has the highest GPA from this side, whereas Bob has the highest GPA from this side. Okay, so if I want to find the student with the highest GPA from from the whole class, so do I need to check the GPA of all the students from A and B?
No, just the first two.
Yeah, so I just need to compare Alice and Bob, and to say, okay, whichever has a higher GPA should be the best or the top student from the whole class, right? Am I correct?
Yes.
Yeah.
Okay.
Yeah.
Same over here. Okay, so here we want if we want to get if we want to merge these two sorted subarrays and get this array as a long and sorted one. So what value should be at the first place at here? Which value should go over here?
1.
Yes. Or to be general, the smallest among the two subarrays, right? The smallest among the smallest value among the two subarrays should go over here. Am I correct?
Yes.
Yes. Okay. So okay, to find the smallest value among the two sorted subarrays. So what can we do? What do we need to do?
Compare
the first
L1 and R1. Yeah.
Yes, we just need to compare the smallest from L and the smallest from R, and to say which one is smaller. So whichever is smaller should go over here, right?
Yes.
Okay, and that, so if you understand that procedure, it's super easy for you to understand the if and else loop, the if and else statement. Okay, what we do is that first we are comparing Li, and Rj. At the first place, we have I and J as 1. So Li is the smallest from L, and Rj is the smallest from R. So we're comparing the two smallest numbers from this the smallest numbers from these two arrays, and to say which one is smaller. So if Li is less than or equal to Rj, meaning that the left smallest is smaller than or equal to the right smallest, we're going to do this. But however, in our example, the relation is that we have Li as 2, and we have Li as 2, and we have Rj as 1. So the right smallest is smaller. So then this is going to be a false, right?
Yes.
Yes.
So we go to the else. In the else, we are going to assign Rj to Ak. We're going to assign Rj to Ak. So what we do is that we're going to assign this value, Rj, to Ak over here. So the reason why we assign Rj but rather than Li is because Rj is smaller. So Rj, so this is the smallest value among the two arrays, right?
Yeah.
Any questions so far?
No, pretty straightforward.
Okay, cool. So we'll copy it over here. So now this value is overwritten from, so it has a new value as 1, okay? And the next, we're going to execute this line with j++. So we're going to increase j by 1. So the new value of j is going to be 2. So we're going to move j over here. The reason why we want to move j over here is because this value is already gone. We already move so settle this value. We already move this value. We already moved this value to the correct place. So we don't need to look at it anymore. So we just focus our eye. So basically, it's like we already delete this number from the array I, array R, and then from the remaining numbers, the smallest one in the array R, in the subarray R is pointed by J, is at index 2. So that's why we increase J by 1. And then we go back to the for loop again. We go back, so after we execute J++, we go back to the for loop. So we increase K by 1, and the new value of K has a new value as 10. The new value of K is 10. And so and to write down R as 16. So the largest value of R is 16. So next, we're going to compare Li and Rj again. We're going to compare Li and Rj. So what is Li?
2.
What about Rj?
2.
Yes, both of them are 2. So if there is a dual, if there is a dual, we prefer to pick values from the
L.
left hand side. Okay, so because this is going to be true, and what we do is that we are going to execute AK as Li. So we're going to copy the value from Li to AK. So Li is over here, and we're going to copy the to AK over here. So we're going to copy the smallest value from Li to AK. And then AK has a new value as 2. And then we're going to execute this line I++. So then the I has a new value. So this value is like this value is gone, and then I has a new value as 2. We're going to have I over here. Okay, so okay, next we go back to the for loop and we increase K by 1. So K has a new value 11. And then we're going to, so in order for us to continue, do you need to read the pseudocode? Do you need to check the pseudocode?
No.
No, it's pretty straightforward. We can just operate over the numbers, over the example. Okay, so basically we're going to compare Li with Rj. So whichever is smaller goes to AK, and then we're going to increase the index so correspondingly, right? So so next, what we do is that we compare Li with Rj. Which one is smaller?
RJ.
Rj. So Rj goes to AK. So we are going to have Rj to AK. So then this value becomes 2. So, and then we are going to increase J by 1. Because it's like this value is gone, and we are going to increase J by 1. And then we're going to increase K by 1. Okay, K is here. And then in the next iteration, we're going to compare Li, which is 4, with Rj, which is 3. Which one is smaller?
RJ.
Rj. So Rj goes to AK. So it has a new value, 3. And it's like this value is gone, and then we're going to increase J by 1. J reaches here, J reaches 4, and we're going to increase K by 1. K is here. Okay, so then we're going to compare Li with Rj. Which one is smaller?
I
Li, yes, Li is smaller. So Li is 4 and Rj is 6. So we're going to copy Li to AK over here. So then we give the new value as 4. Okay, as 4. And this value is gone. So then we are going to increase I by 1. And similarly, we're going to increase K by 1. Okay, so next we're going to compare Li with Rj. Which one is smaller?
Li.
Li. Okay, so Li goes to, sorry, this should be K. This variable should be K, not I. So then we copy Li to AK. So it has a new value, 5. Okay, next, and we are going to increase I and K by 1 correspondingly. So I and K. So next, in the next iteration, we're going to compare Li with Rj. Which one is it goes to AK?
RJ.
Rj, yes, Rj is 6. So Rj goes to AK. So up over here, and then it's going to have a new value, 6. And then we're going to, so it's like this value is gone. So we are going to increase J by 1 and K by 1. So J goes to here, and the K goes to here, right? Okay, so now is it clear why we append an infinity to the end of L and R? Is it clear?
Yes, it is.
Yes. So next we're going to compare Li with Rj, and actually here we are the original values from all the original values from the right array have been used up. We used up 1, 2, 3, 6. So the only number that has not gone to the array A is Li, right? This value. So it must be this value who go over here. But just to ensure that this value can go over there, we need to make sure that Li is less than Rj. Okay, so whatever value we have in Li, we want it to be less than Rj. So that's why we append an infinity to the end, because with this infinity, it's guaranteed that the last value goes to the last position in the array.
Professor, how do you make an infinity symbol when writing code?
Okay, so this is a very good question. How do you define infinity in Java? In Java, actually, if you use this one, integer dot max value, there is a macro called integer dot max value. So this is a constant that stands for the maximum value that an integer can have. This is like the infinity for integers. Make sense?
Yes.
Yeah.
Okay. So here in the last round, we're going to compare Li with Rj, and of course Li is smaller, so we're going to move Li over Ak. So then it has a new value of 7, and so we are going to cross it over, and then we're going to increase I by 1, and similarly we're going to increase K by 1. So when we increase K to 1, we find that K is already exceeding its upper bound. So we just terminate the for loop, and then we finish the whole code. After the time when we finish the whole code, let's say the values in the subarray, the values over here. So now we got 1, 2, 2, 3, 4, 5, 6, 7. Are they sorted?
Yes, they are.
Yes.
Yes. So that's how we manage to combine two sorted subarrays into a long unsorted subarray. Make sense?
Yeah.
Okay. Any question?
So you would use a merge sort with like very large arrays then?
I mean, you can use merge sort on an array of any size. Yes, it doesn't have to be that large.
So like compared to the insertion sort, like which one would we use like depending on like the size of the array, right?
Okay, which one are we going to use depending on the size of the array? Okay, here I'm just going to give you an example. So suppose here you are given two cars. The first one is a Toyota Prius. Let's say the second one, I don't know. So give me a fast car.
Lamborghini.
Okay.
Or yes, maybe a Tesla S, Model S. Okay, Tesla Model S. So which one? So if you are giving these two cars, no matter going anywhere, which car are you going to drive?
The Model S.
Yes, because it's always faster. It's always better, right? So yes. And
yeah.
So your question is that okay? If so under which condition should we use insertion sort, and under which condition are we going to use merge sort? The thing is that in terms of the execution speed, insertion sort is like a Prius, whereas merge sort is like a Model S.
Yeah, that makes sense.
The reason why I'm saying this is that from the complexity side, the insertion sort, the worst case complexity of insertion sort is O(n) squared, and then the worst case time complexity of merge sort is O(n) log n. Which one is better?
The O(n) log n?
Yes, this one is smaller. This one is in terms of the value, this one is smaller, meaning that when you increase the size of the array, the insertion. So if we take this figure, okay, so if this is n, then if merge sort is something like this, and then this is the execution time, and insertion sort is something like this. Okay, so it's always better to use merge sort. Okay, so then this is the merge algorithm, and believe it or not, we haven't finished the merge sort yet because we just finished talking about merge over here, and then as you know that we don't need to do anything for concur, so we can skip that. But for the divide part, we have another function named merge sort, and then but it's quite easy. And here I'm just going to show you the pseudocode of merge sort algorithm. So it takes the divide algorithm. So here we are giving three. So we're giving 3 input parameters: capital A, P, and R. So capital A is the array. What about P and R?
Isn't it the start of the left subarray and then the end of the right subarray?
Over here, there is no left or right, because when we are doing the division, when we divide the array, look over here. We don't care about it is look over here. We don't care about it is a left or right. There is no left or right. Only after division we got left and right?
Yeah.
Okay, so when we divide it, what we want to know is that what is the beginning of the subarray and what is the end of the subarray that we want to divide.
So are you finding the median?
Sorry?
Are you finding the median?
But the P and so not yet. We're not at that step yet. So here, for example, if I ask you to divide this subarray, what we want to know is that where does this subarray begin and where does this subarray end? So that you can know, okay, you need to focus on this area.
Oh, it's first and last index then?
Yes, cool. Yes, I already see the answer in the chat area. So P is P is basically the index of the beginning index, the beginning, and P and R are the beginning and end index of the subarray that we want to divide. Okay, so beginning and ending index of the subarray that we want to divide. And so if P, so let's look at the pseudocode. And if P is less than R, okay, so what if P is equal to R? If P equal to R, what does that mean?
It's sorted?
No. It means that the subarray that we want to divide begins and ends at the same position. Or it means that the subarray that we want to divide only includes one element. Its length is 1. So it's like this.
The conquer stage, right?
Yes, it's like you are giving, so we are reaching the ending stage of the dividing step. So we are now, say if you are giving a subarray of length 1, you don't need to, you should stop the division. There is no need for you to divide, right? Okay, that's why we have it over here. If P is less than R, we do something. Otherwise, if P is equal to R, we're not going to do anything, because there is no need for us to divide it. Are you still with me?
Yeah.
Yeah.
Okay, so if P is less than R, it means that the array includes at least length is 2. So there are at least 2 elements in the array. So there is a need for us to divide it. So first, it calculates this. Q is the P plus R divided by 2. And do you know what does this mean? What does this operator mean? What does this operator mean?
Is that what I said before?
Yes, the floor. So for example, if P is 1 and Q is, if P is 1 and R is 2, so divided by 2 is going to be, this is going to be the floor of 1.5, which is 1. Okay, so it handles, with the floor, it handles the situation where we got something like a decimal value over here, not an integer value after the division. So basically, you can say that Q is the average of P and R, right? Correct?
Mm-hmm.
Yeah.
Yeah.
Okay. Or to make it better, Q is like the middle point, right? Q is the middle point between P and R. Or Q is the index of the middle point of the subarray. Am I right?
Yeah, that makes sense.
Yeah.
Okay, so this is the middle point. And so here we calculate, we just calculate where is the middle point. And then, so as you can see that we need to, so the way for us to cut it is pretty simple. We don't physically cut it. We don't physically cut the subarray. Instead, we treat the left part whose starting index is P and whose end index is Q as one subarray. And we call the merge sort algorithm over this part to further cut this part. And then we call the merge sort algorithm on the left part, whose beginning index is Q plus 1, whose end index is R, to further cut it and sort it, to further cut and sort it. And finally, after we cut them and sort these two subarrays, we call the merge function to, like we learned over here, to merge these two sorted and subarrays into a big a long sorted subarray. Make sense?
What if P is greater than R?
I mean, let me ask you this question, okay? If P is the beginning index and R is the ending index, is there a possibility for P to be larger than R?
No.
Right. See, it's guaranteed if P is the beginning index and R is the ending index, it's guaranteed that P is less than or equal to R. There is no possibility for P to be larger than R. Right?
Yeah.
Okay. So, and here I got one more question from the chat area asking if P is the first index and R is the last index. I mean, P is the first index of the subarray, and R is the first index of R is the last index of the subarray. So it does not have, P and R does not have to be the beginning and index of the whole array. If P and R are the beginning and end index of the whole array, it's guaranteed that P is 0 and R is something like n-1. If we talk about Java, if we use the index convention of Java. But here, because P and R can be any value, because we are talking about a subarray. A subarray can be something like this one, or like this one.
You said it, Professor. You said merge sort is recursive, right?
Yes, merge
So,
sort is recursive.
It calls on itself, like it calls on
Yes.
the merge sort. Okay.
Yes. Okay. Any question? Any other question regarding merge sort?
So would that be how many times it calls on itself then?
How many times to call itself?
Yeah, like the one we see on the screen right now. Is that how many times?
Which one? O n log n? Do you mean O n log n?
Yeah, sure.
Let me say, on average, I'm just give you say how many. Okay, we are going to call the merge sort function n times in total. We're going to call it n times, and each call of the merge sort takes log n complexity. You don't have to know such details, okay? But the thing is that if you are interested, if you want to pursue a graduate study, especially a PhD in computer science, you need to go over the book to know the details about the complexity analysis, why it is O n log n. That is research is something like that.
So that's beyond the scope of this course, pretty much.
Sorry?
That's beyond the scope of this course as to
Of
why
course,
it's ON
yes,
login.
it's out of the scope. I'm just giving you the conclusion, and so that you can memorize in your mind, in your brain, and take the answer. Just give the answer in your job interviews. Okay. Any other question regarding to the the merge sort? I mean, just so I just want to know how many students are lost up to now at this point. If you're lost, just type in one in the chat area. Feel free.
So merge sort is it's its own function, right? Like what's it called? Sorry.
Recursive.
Mhm.
Yes, because it's keep calling itself, and this is if a function keeps calls itself, we say this is a recursive function.
But
Yeah, I
it,
think.
it's
Oh, sorry.
no, go ahead.
Yeah, I think I get it. It's just I think I need to see it or like practice it to like fully get what's
Yeah.
happening.
Yeah.
Does
Okay.
merge sort order P to Q and then Q plus 1 to R? Or the arrays naturally is in order, right?
No. So if you call merge sort, if you finish merge sort, it will make sure that the subarray from P to Q and the subarray from Q plus 1 to R are sorted.
Okay, make sure that that's the case. Okay.
Okay. So from the chat area, I got a question. Is there anywhere we can practice the program? Your homework. This is going to be your homework too. Okay, so in your homework too, you are going to translate the merge sort algorithm you're going to translate the merge sort and merge function from pseudocode to Java.
Is homework 1 just first week's class, or does it include this week as well?
No, for homework 1 only includes insertion sort, and homework 2 is merge sort.
Okay.
Okay, any other question? Okay, so if now, let's take a break for 5 minutes, and we'll be back at, let's say what time? We'll be back at 7:13. Okay, let's let everybody have a rest with their mind and with their brain, and then we'll be back soon.
Okay, thank you, Professor.
Thank you.
Professor, my foundations is a bit shaky. So I understand the math part of it, like I'm a math major, but our arrays, so merge sort makes sure that the arrays are already sorted, but arrays normally aren't sorted by themselves. You
Yes.
have to write the code to to sort them.
No, if you execute the merge sort algorithm on a part of the array, by the end of it, by the end you finish it, that subarray is sorted.
So what if you can already sort an array using merge sort, why do you need to use merge? Oh wait, because the merge was at the end of that code that you sent
Yes.
us. Yeah, okay,
Yes.
okay. I had brain lag.
Okay, let's have a small rest and then come back. So let's continue. And so far we just go over the merge sort and the insertion sort algorithm. And so I also prepare a Java review slides for those of you who are not familiar with Java to recap it. And the slides are over here. It covers some basic things like array operations and how to define class and something like the static functions. But today we don't have time to go over the details of it. But feel free to read it by yourself. And then at the end of the slides, I include some resources for you to study Java by yourself. So the first one is Java 101, and this one I would say probably you can finish it within 2 to 3 hours. And this one is relatively short. So this is a web page that includes something where you can practice your programming, and so it's relatively lightweight. So if you are short of time, whereas you want to, your Java is not very good, you definitely need to go for this one. Whereas if you are, so if you have more time, you can go for either one of the following 2 tutorials. So they are more detailed. They include more details, and each of them is going to take you around 6 hours. So, but after those 6 hours, you should have a much better understanding of Java. And so today, I'm not going to cover this part because I think especially the students in our section are really good at Java, especially considering that I see quite a few of you have already finished homework 1, which is pretty shocking for me. And I'm very glad that because if you start your homework early and finish your homework early, on the one hand, it means that you are very active, and you are very positive for study. You are well motivated for learning. And on the other hand, actually, it helps you to reduce the level of difficulty when you're doing the homework. And so today, my task is to help you go over something that is more practical. So actually, so I'm going to present from my laptop. Share screen. I'm going to share my screen with you right here. So can you see it?
Yeah, we can see.
Okay.
Yeah, I can see it.
Yep.
Okay, here I want to show you, especially some of you who are not very familiar with programming Java. Okay, so I want to show you how to start your homework. So previously, if you see if you go to Canvas, you should be able to find the pseudo code that I provided for you. And on my laptop, it's just right over here. So okay, on my laptop, it's just over here. You can open it up, and here, so first I'm going to show you how to start your homework. Okay, so if you want to start your homework, if you use your an IDE like Eclipse or IntelliJ, the first thing that you need to do is to create a project. A project is like a workspace for you to to write your code, and so let me see what kind of chat. Okay, I can see it's fine for me. Okay, so you can take a project as a workspace. It's like a folder that includes all of your codes and all of the binary programs based on your source code. So let's say for now, let's give the project a name says IT212 Spring 21. Okay, so you can give actually you can give it any name and go to next, go next, and then so just finish. So here on the left hand side, you can see you should be able to see the project that we just created. And here under it, there is a folder. There is a folder named SRC. Can you see it? Can you see the SRC folder?
Yes, I can.
Yes.
I can
Okay,
see it.
Yes, SRC is basically is basically in short for source. So this is the place where you should put your source code or all of the Java code in. So, but it's not. So if you have many different files, it's not a good practice to put all of the hundred of files inside the same folder. It's going to be too junky for the search for something. So then in Java we have something called a package. So package, you can take a package as subfolder. So we usually put the code with the similar purpose under the same package and give it a package name. So for example here, so here you can right click the source folder and then click new package. So here, so with that, you will be able to create a new package. And over here, we can give a name called sorting, because in the first couple of weeks, all of our source code, all of our tasks are going to be dealing with sorting algorithms. Okay, so after that, you'll be able to say such a package named sorting, and now it is empty because we don't have any source code in. The reason why you need to give it a name, the package name sorting, is because in the skeleton code that I provide to you, so in the first line it says package sorting. So you should, so if the first line has a package sorting, you need to make sure that this code, this piece of code, stays in a package named sorting. And then and also if you look at the class, the name of the class that I define is it's a sort. So next we need to create within this folder, within this package named the sorting, we need to create a new class named sort. So this name has to be the same with this one over here. Okay, so they have to be consistent, and so just specify the name of the class as sort, and then you finish. So so you should be able to say, sorry, my laptop is I always I'm torturing my laptop by running a lot of programs. So that's why it's so slow. Okay, and here you can say, and so after doing that, Eclipse will automatically generate a skeleton code for you. The first line is package sorting. This is because you create your class file inside the a package and then the sorting. And start, okay, after doing that, you should be able to, you can just copy and paste the files that the skeleton code that I provide to you over here. And then you can just go to execute this code for free. So now you should be able to see the output. Okay, so this is how you should start your program, your homework. Okay, so and next, the other thing that I want to teach you is the debugging features that are provided by Eclipse. So I'm just going to a different project. Here, Java review. So here I define a class named student, and inside the student class, I define a function, a static function named calculate GPA. So what this function does is that it takes a list, a double array, an array of double values, or so named grades. So basically, it takes a list of grades that the students have received, and it's going to calculate the purpose of this piece of code is to calculate the GPA of the student. And the logic is pretty simple. We basically sum up the grades received by the student and then divide it by the number of classes that the student have taken. And then that will be the GPA. So pretty straightforward, right? Okay, so over here, I'm just going to show you, I'm just going to use this as an example to show you that the various types of arrows that you are going to see when you are doing your homework. The first type of arrow that you are going to see when you are implementing a certain algorithm is called compile time arrow. A compile time arrow is like you write a piece of code with grammar arrows. Or it's like you write an email with a lot of typos. So if you say in real life, if you write an email with typos, you should not send it out. You should use some like editors, for example, Word, to check to do some grammar errors for you and fix them before you send them out. Similar here, if your code has a grammar error, let's say, for example, our purpose over here is to create a double array of the for student. So for example, if the student has taken 3 courses and the grades that the student received are 2.0, 2.5, and 3.5, they want to calculate the GPA for the student by calling the calculate GPA function and print out the GPA. So here, let's say, what if with the current code, with the code as in the current shape, if we execute it, the output that we see, I'm just going to comment out the first. So I'm just going to comment out first couple of lines and just going to focus on the last part. So okay, so that is easier for you. I'm going to execute it again. So because currently the calculate GPA function, the whole piece of code is written correctly. So we can see that the GPA for the student is 2.666, which is correct. And now I'm going to show you different types of errors that you may encounter when you are writing your code. So one type, as I said, one type of error is called compile time error. It's like grammar error in your code. For example, if you forget to have a semicolon in your code, and then you can say that if you delete that, it's like you are writing a sentence without a period at the end of it. So the IDE itself is able to detect it by signaling, okay, such a red cross on the left-hand side. It basically tells you at this line there is a grammar error. Okay, you should fix it, and sometimes it gives you the hint on how to fix it. So here you can see that it says syntax error, insert semicolon to complete this sentence. So then, but if you don't fix it, if you don't fix the compile time error or the grammar error, you cannot even execute your code. So for example, here, if you want to execute the code, it will just say, okay, exception in thread main java.long.arrow unresolved compilation problems. It's like so if we translate this sentence into human language, like your code includes some grammar error, I cannot even understand it. So I cannot execute it. So your code is not going to be executable if your code has compile time error. But this type of error is very easy to fix. So your IDE already specifies it for you. Okay, and then let's say the other type of code. So here, if we insert if we use I is less than and equal to the length of the array, rather than I is less than the length of the array. So now our code has no grammar error. So we are able to execute it, and so we can execute it in here. But you can see this time we can execute the code. We can execute the code. But the thing is that it gives you some to show you, to really show you that we can execute the code. I'm just going to type in some sentences over here saying that system.out.line start calculation. Start calculation. Okay, so let's re-execute the code. So here, what we are going to say is that, okay, we are going to say, if we see that our code is being successfully executed because we already say the print message, start calculation. But the thing is that your code, you got the runtime error. Still, it sends out. So if you see something in the red color, that means that your code. So the execution of your code so faces some error. There is some error when Java virtual machine is executing your code, and we call this type of code this type of error runtime error. So runtime error means that you are able to execute your code, but you got an error. So how to fix this type of the error when you are doing your homework? So you can see that if you go to the last line of the error message, it says, okay, sorry, let's go to the first line of the error message saying exception in thread main, and so the type of error is this: java.long.array index out of bounds exception. So if you copy and paste this, so this is basically the type of error. This tells you what type of error you are receiving. And if you copy and paste this tag to, say, for example, to Google, and you should be able to say, so a document provided by Oracle, and if you go step into that, so this is the definition. This is a class that defines this type of error called array index out of bounds exception. And so the reason why you are getting this error is that by reading this document, you'll be able to see, okay, what does this error mean? Here it means that it says, okay, the arrow is thrown to indicate that an array has been accessed with an illegal index. The index is either negative or greater than or equal to the size of the array, which is pretty simple, very easy for us to understand. We are using an invalid index to access the elements of the array, and the index is either negative or greater than or equal to the size of the array. And over here, if we come back to the to here, it says it follows a value 3. 3 means that you are using when you are using the index 3, the arrow is triggered when you are using the index 3 to retrieve to access elements in the array. So which is pretty okay. And then if you go to the last if you go to the last line of the error message, it will point you to the place where you trigger the arrow. So you trigger the arrow when you are executing this line, and in the second last line, if you click that, it shows you the nearest place when you trigger the arrow. Okay, basically you trigger this arrow. You trigger this arrow when you are executing this line when the index is 3, when the index over here is 3. Okay, so so now you know, okay, you are triggering this arrow when you are when the index is 3. So you should not let the index reach 3. So that's why you should remove the equal sign. And after that, you should be able to fix your code. And now you can execute your code correctly. So this is how you are going to fix your runtime error, meaning that the error. So your runtime error means, again, runtime error means that your code does not have any grammar error. You're able to execute it, but you got some error when you're doing the execution. Your code cannot be executed successfully. And then, so the last type of error is called logical error. This type of error is the most difficult one for us to debug. So logical error meaning that you are able to run your code successfully from the beginning to the end, but you don't get the correct output. You don't get the expected result. So the result is wrong. So to fix this type of code, to fix this type of problem, you will need to use the debug features of your IDE. So last class, some students asked me, okay, so what kind of IDE should you use? I said you're free to use anyone, like Intel J, like Eclipse, or Xcode. So I'm fine. But also I said personally, I recommend you to use Eclipse. The reason is that among this, so I have used almost all of them. And personally, I think the debugging features provided by Eclipse is the best. So, and I'm going to teach you some how to use the debugging features with Eclipse today. And so this thing, throughout I've spent how many years? 13 years in the world of computer science. No one has ever taught me anything about debugging. And if you go to YouTube, you search for something like debugging in Eclipse, there is very limited amount of resources. So I basically learned by myself through many years of experience, and I just devote a lot of time to exploring those features. So I think the next part of the lecture is going to be really valuable. This is based on at least 7 or 8 years of my Java experience, Java programming experience. So okay, so here let's say, what if we just get this one? Okay, if we implement the code without any grammar error, and we're able to execute it, but so you can see now we're able to execute it, but we see an output, the GPA output as 1.5, and obviously this is wrong because 1.5 is lower than every grade that the student received. So there must be something wrong with the calculated GPA function. So how are we going to say go over the code and fix it? So we need to the best way to fix the code is to go over it step by step to say what are the variables, what are the variable values, and to so that we are able to know, well, where is the problem, and to be able to execute the code step by step, we need to first, on the left hand side, we can double click, and then it will show a blue button, a blue circle. By double clicking it again, so it disappears. So here, so basically, if you are suspecting that one line of your one function of your code is incorrect, you just need to set up such a thing we call this breakpoint or stop sign. So with this stop sign, if you go to debug your code, not run your code, but debug your code, it will, so the Java virtual machine, when Java virtual machine executes your code, it will respect the stop signs. So what it does is that it will make a stop. It will make a stop before the breakpoints. So now, we see the green color in this line. We see the green color in this line because they just make a stop before this line. They just finish the first line and it makes a stop at this line. So here on the top right, we can see a tab named variables. So in the variables area, it shows all the variable values that it shows the values of all the variables that we have created. So here you can see that we got a variable named grades, and the grades has three elements: 2.0, 2.5, 2.3. That is based on the execution result from the previous line over here. Okay, so we are just making a stop before executing the line with number 73. So what we really want to do is that we want to step into the calculate GPA function to inspect what is going on. So here, if you go to run, and you'll be able to see two things. You are going to mostly use two things. The first thing is called step into, and the second function is named step over. Step into is like to enter a certain function, while step over is to just execute the next line. So here, because we want to enter the calculated GPA function, we're going to click on the step into.
Something big for like lovers or whatever. He's like, you saw
We're going to click into the step
these are like
into.
huge ass shrimp. So Charlie's like, we'll do this. So she's like, I need to see your IDs.
Okay, so if you are,
So Charlie has a steak.
I mean,
so he gets a steak. I'm like, oh, I
could you
switched
please
that
turn off your
to
mic?
back so I can bring one.
Okay, and then let's come back. So so here we just click the step into function, and then we go over here. So here it just enters. Now it just we enter the calculate GPA function, and it is making a stop before this line, before the system.out.print line. So now we want to execute the code line by line. So we can go to use the step over function that is provided by Eclipse. Because we execute step over, so now it just execute this line, and then so that we are able to say this print out, start calculation. So next, we want to execute this line too, sum equal to 0, line 2, line 42. So we go to click step over. So after executing this line, if you go to the variable area over at the top right, we are able to see a new variable named sum, whose initial value is 0.0. And then we want to execute the for loop line by line, iteration by iteration, to say what is going on. So we go to click the step over button again, and then so it just start the for loop with so now we can see an integer value I whose value is 0, and then we have, so now we want to execute this line, the following line with sum plus equal grids I. So we can go to here and execute step over. So after executing this line, the value of sum is changed. It goes it becomes 2.0. Originally it was 0.0. So now we see, okay, the value changed. We sum up the first grid from the grids vector. So okay, and then we execute the step over again. So it just go back to the start another iteration and increase I to 1. Originally it was 0. Before that it was 0, and then we execute the step over again. So we can say now sum has a new value. Sum becomes 4.5 because we just add up the second grid. And then so if we execute step over again, we see that okay, now we just finished the for loop, and we're about to calculate the GPA. But at the time when we finish the for loop, the value of sum is 4.5, which is different than our expectation. It should be 2.0 plus 2.5 plus 3.5, 8. So we know okay, the error comes from the for loop, because we should have executed one more iteration. So to fix the problem, we just need to delete the -1, and then so here, because we pinpoint the problem and fix the problem, we can just click the blue the red square to terminate the debug. So we want to terminate the debug, and then we can go back to the Java view. So this is the Java view, and then we can execute the code again to say if it is correct. Yes, now we see the output over here, start calculation. We see the correct output of 2.6 something. So this is what do we expect the answer to be? Okay, so this is how can you fix the most difficult error named logical error, meaning that you can execute your code successfully, but it just gives you the incorrect output. How are you going to fix it? You are going to depend on the debug features that are provided by your IDE. And among these different options of IDE, I personally recommend Eclipse. Okay, so this is based on my Java programming experience. Any question?
Yeah, can you repeat what step into does again?
Step into is like enter. So because this over here where we are at this line, we are executing another function, right? So I'm just going to show you what if we don't use step into over this line. What if we just use step over? Step over is to just execute this line in a whole. It will finish the execution of the calculated GPA function in one step. It will not go into this function and execute it step by step. So if we use step over rather than step into, previously we used step into, so we can go to we can start the execution from here line by line, right? But here, if we do not use step into, we just use step over, it will just finish everything in a line. It's just treats this whole piece of this line of code as one thing, as one unit, and execute this unit. So then you basically finish the execution of the whole code.
Yeah, I get it. Thank you.
Okay. Any other question? No? Okay, so then that's pretty much our lecture for today. And your homework 2 is available starting from today. It's going to due next Friday on February 28. Yes, I think it's on February 20. No, not 20, 26 or 27. I don't know. It's just next Friday. So take your time. And for those of you who have not started homework 1 yet, it's time to start it. We don't want to forget everything, and so things will be much more difficult.
I got another question, Professor.
Sure.
I finished the homework. So if the output is all true, that means the code is correct, right?
Yes. Yes.
Okay, thank you. I didn't submit it yet because I wasn't sure.
Okay.
Question. Does it have to be a zipped file, or I could just directly drop the folder?
Okay, so cool. This question. Thank you for asking this question. So in your homework 1, you are supposed to write a .java file, and also something like a Word file to show the figure, right?
Yeah.
So what I encourage you to do is to create a zip file from these 2 files and upload the zip file. Because I think that Canvas only allows you to upload 1 file.
Yeah. Okay. Thank you.
And any other question?
So should we export the entire project then into a zip?
No need. Just your .java file.
Oh, okay. Thank you.
Oh, Professor, when you were explaining the classes and packages, can you use information from a different source folder in a class?
What do you
Or
mean?
like
can you use information from
a different source?
I don't quite get your question.
So could you like call on a function or a formula? Like you can call it from something from the same package, but can you call it from like a different project?
Yes, but you need to. Okay, you can use everything inside the same project, but if you want to use something out from a different project, you need to create a package create a jar file from that project and import that jar file into your current project.
I see. Okay. Thank you.
Yes, it's like you take the other project as another project as a library.
Okay. Have a good week, everyone.
Yeah, have a good weekend. Have a good week, not a weekend yet.
Yeah, have a good week. Bye.
Bye.
Thank you, Professor. Have a good
Thank
night.
you.
Thanks, teacher.
Thank you.
Thank you. Have a good night.
Good night.
Have a good night. Bye.
Good night, Professor.
Good night.
Good night.